So questions from the homework. Gabriel? 15. Yeah, that'll work. So 15 is we want to prove that tangent x plus cotangent x all over secant squared x is equal to just cotangent x. And this is kind of a hard one. There's a hint that tells you what to do. It says, hint, try converting everything to sines and cosines and then simplifying the resulting complex fraction. So as usual, what we're going to do is we're just going to work with one side of the equation, right? You shouldn't be copying any equal signs anywhere. I'm just going to work with the more complicated side, and I'm going to simplify it and transform it, and hopefully it'll just magically turn into cotangent. So the hint says to convert everything to sines and cosines. Well, okay, let's do that. So here's my big fraction bar. What's tangent in terms of sine and cosine? This should be instantaneous. Shout it out, guys. Sine over cosine. Good. Tangent is sine over cosine. Okay. Plus, all right, cotangent. What is cotangent in terms of sine and cosine? Cosine over sine. Good. Okay. Now, secant squared. What's secant in terms of sine and cosine? Secant is 1 over cosine, right? But of course, this is secant squared. So secant squared is 1 over cosine squared. Is that okay, guys? So we've converted everything to sines and cosines, as the hint suggested. And what we have now is a complex fraction, right? We have fractions within fractions. And how do you handle that? Well, we kind of reviewed this before the break, but what you need to do is make the entire top a single fraction and make the entire bottom a single fraction. And then you can do keep it, change it, flip it. Does that make sense? The bottom, of course, is already a single fraction. The bottom doesn't really need to be modified, but the top is actually two fractions being added together. We need to combine them into a single fraction. And the way to do that is to obtain common denominators between these two fractions. So I'll multiply top and bottom of this first fraction by sine of x. And I'll multiply top and bottom of the second fraction by cosine. And then they will have common denominators. So let's go ahead and do that. So here's my big fraction bar. Multiply top and bottom here by sine. I get sine squared x over sine x cosine x. Is that okay, guys? And then multiplying top and bottom of this expression by cosine, I get cosine squared x over sine of x cosine x. Is that okay? The bottom, like I said, is already a single fraction. It doesn't need to be modified, so I'm not going to change it at all. All right, so now that these two guys have common denominators, I can combine them into a single fraction. So let's go ahead and do that. What does that give me? So here's my big fraction bar. On top, what do I have? These two fractions become one fraction. The denominator stays the same between them, right? It's just going to be sine x cosine x. But the numerator, you actually add them. So the numerator is going to be sine squared plus cosine squared. All over 1 over cosine squared x. We good so far? Cool. All right, now what do you notice? Something should go blip, blip, blip in your mind. Yeah, no? Yeah, this guy right here, sine squared plus cosine squared, that's equal to 1. So anytime you see sine squared plus cosine squared, you should replace that with 1. let's go ahead and do that. That's going to leave me with, so here's my big fraction bar. 1 over sine x cosine x all over 1 over cosine squared x. Is that okay, guys? So I think now I'm ready to keep it, change it, flip it. I've got one fraction divided by another fraction. So keep the top, change this to multiplication, and take the reciprocal of this. By the way, do you notice that I always use a larger fraction bar for like the larger fraction? You should definitely do that. Because if you just have like A over B over C, it's really not clear what that means. That could actually mean two different things. You want to make sure you use a larger fraction bar for the outermost fraction. Anyway, yeah, so let's keep it, change it, flip it on this guy, and then we're pretty much almost there. So that's going to be 1 over, so I'm going to keep the top fraction as it is. So that's going to be 1 over sine x cosine x times, and then I flip this bottom one upside down. So that's cosine squared x over 1. What do you notice now? What can be done here? Yep, Colin.
You cancel the cosine.
Yeah, there's some common factors that you can cancel. There's a cosine x down here, and there's a cosine squared x here. So there is a common factor of cosine that can be canceled. Of course, there's really 2 copies of cosine in this numerator here. So after cancellation, there's still going to be a copy of cosine left over. Is that okay? It's as though you had an x down here and an x squared up here, right? After cancellation, you'd still have 1 copy of x up top. So, okay, so that's going to leave me with 1 over just sine of x, right? So that's going to go away. Times, and like I said, I still have 1 copy of cosine up top. All right, well, you know, you're multiplying 2 fractions. That means you multiply across the top and the bottom. So that's 1 times cosine, which is, of course, just cosine over sine times 1, which is just sine. And cosine over sine, that's better known as what? Cotangent, which is exactly what we were hoping it would turn into. And there it is. Is that okay? So this is really common, like converting, this is a really common technique. It comes up a lot. You convert everything to sines and cosines. You wind up with a complex fraction. You simplify the complex fraction by getting common denominators, combining everything together, and then you keep it, change it, flip it, and then there's some cancellation. That's very often how these more complicated ones go. Okay. All right, what else? Beyond number 15, what else would you like me to do? I know there's got to be something. I saw some blanks left on people's worksheets. Yep, on 14. That's good. I mean, these are exactly the 2 problems that the other section asked me to do. So, okay, so 14 is we want to show that cotangent x minus tangent x all over sine x cosine x is equal to cosecant squared x minus secant squared x. So like usual, we're just going to take the more complicated side, which is usually the left-hand side, and we're just going to work on that guy and transform it, and hopefully it'll magically turn into the right-hand side, right? Don't be copying an equal sign. Don't be copying both sides of the equation. You're not allowed to do that. So I think there's a hint for this one. Yeah, there is. It says, hint, try converting to sines and cosines, then splitting the fraction. Splitting the fraction. Let's give that a shot. So let's convert. I'll move a little bit more quickly this time than the last one because it's very similar to the last one. So converting everything to sines and cosines on the left-hand side, cotangent is, of course, cosine over sine. minus tangent is sine over cosine. And the denominator of the large fraction is already in terms of sines and cosines. So nothing to do there. Okay. Then it says split the fraction. What does that mean? It means split this larger fraction bar, right? You have one thing minus a second thing, all divided by sine x cosine x. You can split the fraction and write this in the following way. You can write this as cosine x over sine x, that's this first term here, divided by the sine x cosine x, minus this term here, sine x over cosine x, all over sine x cosine x. That's splitting the fraction. Do you see that I split the larger fraction? It's basically distributing the division by sine x cosine x. Is that okay? Now, how do you simplify each of these guys? Each of those guys is a complex fraction, right? You've got fractions inside of fractions. And ultimately, to simplify those things, you need to obtain a single fraction up top, which we already have, and a single fraction down below. Now, the object in the denominator is not a fraction yet, but you can make it one, right? You can make sine x cosine x into a fraction by just putting it over 1. Like, imagine there being an over 1 right there. Do you see what I mean? Now I've got one fraction divided by another. Same thing with this guy here. I can imagine this sine x cosine x as being over 1. And then it's pretty clear how to do the keep it, change it, flip it. Is that okay? I strongly recommend you do that. Like, if one of these guys isn't a fraction, make it a fraction. And it'll become a lot more clear what's happening. Okay, so I'm going to keep it, change it, flip it now. So this first guy, it's going to be cosine over sine times the reciprocal of this bottom one. So cosine x over sine of x times the reciprocal of that guy. So 1 over sine x cosine x. Minus, and then I'm going to do the same thing here. So minus sine x over cosine x times, again, to the reciprocal of this guy. So 1 over sine x cosine x. Okay. So that's what we have. And now we can actually start to clean things up. What do you notice? Anything nice happen? Yep. Avi?
Cancel out sine.
Yeah. Like in this term here, right? We can cancel this sign with that sign. What else? Yeah, the cosines cancel in this first term, don't they? Right? So this cosine will cancel that one. So what's left over? If you like, you can write a 1 here if it helps. So you're multiplying these two fractions. On the top, all that you have is a 1 because it's 1 times 1. And on the bottom, you have just sine times sine, which is sine squared. Minus, likewise here, this is just 1 times 1. So 1 on top, cosine times cosine, that's cosine squared. And that's what we have. That's a lot better than what we had originally. Remember what you're trying to convert this thing to. We're trying to convert this thing to cosecant squared minus secant squared. Do you see that that's exactly what you have here? Right? Because 1 over sine, that's cosecant. So 1 over sine squared is cosecant squared. So that is, in fact, cosecant squared minus secant squared. And voila. Good. Okay, I think I'll stop there.